Hello everyone, welcome back to my channel. My name is Piyush and this is video number 37 in the series CKA 2024. In this video, we'll be looking into application failures, troubleshooting and how to fix the issue from CKA exam perspective. Yes, we have seen a lot of troubleshooting scenarios, a lot of troubleshooting applications, services, different resources within Kubernetes and few other videos like services, namespace and so on. And in this video, we'll be looking into a few of those plus an additional scenarios from the exam perspective. Okay, so I have prepared the GitHub repository for you so that you can do the task by yourself, log into the server, deploy the application, and to fix the issue with the help of a sample application. I will show you everything. The comments and like target of this video is gonna be 100 likes and 100 comments in the next 24 hours. Pretty straightforward, pretty simple. I'm sure you can do that. Okay, so without wasting any time further, let's start the video and let's get into it. Okay, so before logging into our cluster, before starting the troubleshooting scenario, here is our sample application that we'll be using. So let's have a look at that and let's try to understand the application first before we deploy it and before we start working on it. Okay. So this is an example voting app that's been forked from Docker samples. So Docker already has this application to practice Docker, to practice Kubernetes with the help of a sample application, right? The reason why I forked it because I had to make some changes to it from CKA perspective and from this video demonstration perspective, right? Now you can directly clone this repo and start working on it for doing the hands-on, right? So I've already made some changes. I have introduced some errors in the code so that you should be able to identify those and fix those by yourself. Okay, so let's see what do we have over here. So as it says, it has different components. It has a folder which says Kate's specification. That means it has all the Kubernetes manifest. So this is the folder that we'll be working mostly with. And it has a Docker Compose file. A Docker Compose, we did not really looked into it. Maybe we'll do that after the CK series is done. But just try to understand Docker Compose is nothing but a single YAML file with all the containers, all the applications that you want to deploy. So if we open this, okay, so this is not for the demo perspective. I'm just telling you this. So let's say it has different services. Services are votes, then we have results. Okay, so these are different containers that we have. And inside that, we can set the dependencies like this service vote. Okay, the target is dev and it depends on another service which is Redis. Condition is service healthy. So when Redis is healthy, when Redis is up, only then it will start the voting service and so on, right? Then it has this command as well that we mostly specify in the Docker file, um, and volumes, ports, network, everything else, right? So we'll do that later on. Just wanted to give you a gist of it. Okay, so let's have a look at the and here are the instructions how you can start the application if you are just using Docker. And here are the instructions for running it in Kubernetes. So this is what we'll be following. So we have to just deploy all the YAMLs inside the K8 specification folder. Okay, so let's have a look at the architecture. It's over here. All right. So it's straightforward. We have 5 Docker containers, 5 microservices, and we have a user. Okay, we have 2 front-end services. One is a vote and one is a result, right? So these are the 2 front-end application exposed on different ports. This is a Python based, this is Node.js based application. Then what it will do is it also has a service which is Redis. Redis is used for in-memory cache, or it is also used as a messaging service, right? So Redis is collecting votes from the front-end application vote, okay? And the vote is submitted with the click of a button on the voting application. Redis collects that and then Redis stores that vote in a .NET worker. Okay, so .NET worker is another service over here. And then this .NET worker, it consumes the vote. Okay, it does not actually stores the vote. It consumes the vote from the Redis and then it stores into a Postgres database over here, right? And then a result. result front end that we have, which is written in Node.js, it pulls the vote from the database directly. Okay. So again, you can read about it over here, which says what it does, what it is, and so on. Okay, I did added one image over here, but it seems to be broken. Let me see if, okay, I actually, okay, I made a mistake, but it's okay. I'll fix that later on. But let me open the source, like the source image of where I created it. So the diagram that we saw, it was from an application level perspective. Now let's have a look at that from a Kubernetes perspective. Okay, I'm sure this is visible. All right. Okay, so again, same thing because we are basically using the same application. It has one, two, three, four, five services. Services as in we are not talking about Kubernetes services, five services as in five microservices, or you can call it as five application, five containers, and so on. Right. So we have five workloads running. So these five workloads are deployed as separate pods. So we have one pod for the front end Python application, which is the voting application, one pod for the front end Node.js application, which is the result application. Then we have one pod for Redis, one pod for .NET Worker, and one pod for Postgres, okay, which is a database. Now, what happens? Your user access the application, the front end application, which is the voting application, on port 31,000. Okay. Now, because user is accessing this application outside the cluster on a particular port, right? So we know how do we do that with the help of a node port service. So we have exposed this application on 31,000 node port. Okay. So that's the first step. User access the application. Then user inputs the vote. Like it selects. So there are two options. I'll show you afterwards. So it has two options: select cats or dogs. So the user selects one of those options, and then the votes are collected by Redis. Okay, it collects the vote. Again, the front end access the back end with the help of a cluster IP service. Because this is the internal interaction between the services, it doesn't have to be node port, right? It is internal to the cluster. So that is why there we are using a cluster IP. Now there is a .NET worker that consumes the vote after that, and then it stores the vote into Postgres database. Over here again, this Postgres is also exposed as a cluster IP service. Then our Node.js application over here, it pulls the vote from the database. Okay, and again it is using this cluster IP service. So I'm just gonna move it over here, right? So it pulls the vote from Postgres database, and then it displays the vote to the user on port 31001 port. That means this is also a node port service. So these two are node port service, these two are cluster IP, and this one is a worker. It is a queue, or a messaging service, so it doesn't have to be exposed on a particular service port. Okay. So this is the entire architecture of our application, how it works, how it interacts with each other, what is the flow. Like we need to understand the flow of application before we start the troubleshooting, right? So now let's go back to our terminal where it is. Okay, over here. So let me check get nodes. Okay, all my nodes are up and running. Let's see if we have anything deployed. No, we don't have. So let's deploy it. So I have already cloned the GitHub repository, so you can do that. I will share the link as well. So I'm gonna go inside K8 specification folder. Okay. And inside that, because I have to apply all these YAMLs, so I'm gonna do kubectl apply -f and then dot. Dot, that means in the current directory, all the files. Okay. So what does it have? Let's see while it is creating all those things. It has deployments, the pods that we saw. It has services, and it has a network policy as well. So these all should be created. So let's see k get deploy. So we have 1, 2, 3, 4, 5 deployments, and all are up and healthy. If we see k get pods, all the pods are up and healthy. If we see services, we have we have 4 services. One is the default Kubernetes service. So we have 4 services. Okay. And Over here, we can see these two are node port services exposed on port 31,000 and rest of them are cluster IP. Now, if we can do kget net policy, so we'll see the net policy over here. Net policy is applied to the Redis pod because we can see that with the help of pod selector. All right, so everything is created. Our cluster is up, our application is up. Now let's try to access the application. Because we don't have any host, we are not using ingress. So our application should be exposed on port 31,000 and 31,000, but it will not work on these IPs, right? This is the cluster IP. This is not the external IP. External IP is the node IP on which the application is deployed. So let's see if we do k get pods hyphen o wide, let's see on which particular node our application is deployed. So we are looking for a voting application, which is this one. This is deployed on worker 2 and worker 2 IP is 192.160. This looks to be the internal IP, so I don't need that. If we do k get nodes hyphen o wide, okay, so this is the external IP. Nodes, oh, I mean, the IP, I guess, don't be visible over here. We have to get it from the AWS console or from like whichever cloud or whichever virtualization you are using, right? So I'm gonna go back over here and let's see the IP of my worker nodes. So workers IP is this one, public IP. So let's see on port 31,000. So that's one node, it's not reachable. Let's see the other one, which is worker 2. Worker 2's IP is this. Let's see on port 31,000. Okay, this is also not reachable. So there could be some issues with the application, which is why we are doing this video, right? So let's troubleshoot it. Okay, we have already seen all the pods are up and running. That means our workload is running. I don't see any issues with the workload. It is running fine. And you can do describe on it. You can do a log on it. It doesn't matter. But because we are accessing the application on a particular port, that means we are using a service to access the application. So there could be something wrong with the service. So let's have a look at the service. If we do kget service, we see the services are here. And let's do a describe on, okay, describe service on the voting application. Let's start with the vote. Okay, so we see it has namespace is default, labels is app equal to vote, selector is app equal to votes, we have labels, selectors, we have type is node port, we have IPs, we have port exposed 5,000 internally, 31,000 externally, target port is 80, and this endpoints is missing, right? Endpoints is what exposes the application, right? If we don't have the endpoint, that means there is some issue with the application that's being exposed. So that's one thing. And I don't see any event. So let's look at that. Let's open the service YAML. So if we do kget svc vote hyphen o YAML, okay. And over here, where it is. Okay, let's verify everything. And we see over here that the node port is right, the port is right, protocol, target protocol, everything is good. And we see selector over here is app equal to vote. That means this service will be exposing the pod that has a label with the name app and value as votes. Okay, so now let's see if it is same for our case. So if we do kget pods and the pod name is, okay, let's do kget pods hyphen hyphen show labels so that we would see the labels as well. And our pod is vote. Okay, and it has the label as app equal to vote. So yeah, I guess this is visible. So this particular pod vote has the label app equal to vote, and over here we are using selector app equal to votes. So there is this mistake. Okay, so what I'm gonna do, I'm gonna edit the service as we see, and then name is vote. Now I'm gonna go down. Shift G is the shortcut to go at the very end of the line in VI editor. Okay, and then I move up And over here, I'm going to press Shift A. So this will bring the cursor at the end of the line and in the insert mode. Okay, this is again a useful shortcut. So I'm going to delete the extra S and I will save the file with colon WQ and exclamation. Hit enter. It will save the file and it will make the changes. Now let's do k get svc and k describe svc vote. Oops. Okay. And over here, now we see our endpoint is there. That means we have fixed the issue with the application. Now the label, the selector that it uses app equal to vote. This is good. And now we have our endpoint. Now if we do k get endpoints or EP, we'll see the endpoints for voting application, which is this one. Okay. Now let's try to access our application on port 31,000. Okay. Our application is working fine. Now let's try to access the result application. So this is the voting application and we have a result application which is exposed in 31001. Okay, so this doesn't looks to be responding, right? It is still loading the page and it will eventually time out. So let's see again. We have pods running fine. So let's see the services for result. Okay, so there's the service for result, which is again a node port, and let's do a describe on it. Describe svc and result. Let's see over here we do have an endpoint, so that's good. And we do have label equal to uh, app equal to result and selector equal to app equal to result. Okay, the other thing that we need to verify is this service is using the target port as 8080. Is our pod also exposed on the same port or anything else? So let's see if we do k get pod. Okay, let's do a grep on result. Okay, so there is the pod. I'm just gonna copy it. K get pod. Okay, -o YAML. Okay, so let's see the port that the pod is using to expose its container. Okay, so over here we see the container port is 80. Okay, and this name over here, this is the name of the port. We can specify the name for the port as well. This is the optional field, but yes, we can do that. It is important to remember from exam perspective, if there is a task in the exam that asks, so expose the container on a port and with the name as this. So this is how you can do that. Okay, so this container is exposed on port 80, but our service is using port 8080. So we have to make that change. So let's do a edit svc result. Okay, and let's do a shift G, and over here where it says target port, let's change it to port 80. Okay, now let's do k describe again. And over here, the target port is now 80, looks to be fixed. Now let's go back and let's see our application. Okay, now it's showing the result page. So currently it is the default result. It's not really showing it, but your application is accessible. We have fixed the issue. Now, if we go to this page and let's start uh, testing the application, if it is working fine or not. Okay, so let me try to vote. Let's select any one of those. Let's select cat. Okay, let's see if it is working. No, it keeps on loading the page and it is not actually accepting the vote. So if we see over here, now we have fixed this service. We have fixed this service where both the application are accessible. So till here, it's fine. Now there could be issue in submitting the vote. So we have to look into this one over here, the Redis service and the worker service. We have to work on this one. So somehow they are not accepting the vote. There could be something wrong with this service while reaching to this service, right? Front end is not able to reach Redis. So let's see the service for Redis. If we check k get svc, okay, so we have Redis service is a cluster IP exposed in port 6379. Okay, and if we do k describe svc Redis, so over here we see we have endpoints on the same port. We have selector app equal to Redis, and it matches with the pod label as well because the pod name is Redis and this is the default label. So that is good. I don't see any issues with it. We don't have any events as well. So there could be something else. So if you remember, what you can do is you can do k get all to see every resource that was deployed. And you see we have replica sets, we have deployment, we have services, we have pods. Okay. And we also, okay, that resource would not come over here. So we also had something called network policy, right? So network policy, if you remember the network policy video, we have discussed that in detail as well, that network policy is used to restrict or allow certain traffic on certain ports or IP and so on, right? It works like a firewall rule within your cluster. So if we do k get netpol, we have a network policy that's been applied to the Redis pod. So that means this is the point that we'll be looking into. So k describe netpol or network policy, it's one and the same thing. And then access hyphen Redis. Okay, so it says pod selector is app equal to Redis, allowing ingress traffic. So there is an ingress rule to port any, that means traffic allowed on all the ports from pod selector app equal to front end. That means only the pod that has the label app equal to front end is only allowed to reach the Redis pod. Okay, so what we did, or what this application did, so let me try to explain it over here. So there is this pod over here. This is your Redis pod. Okay, now we have attached a network policy to it. All right. This network policy states that only allow the traffic from a pod that has label app is front end. Front end. Okay. So only this traffic will be allowed, and rest of the traffic, like from any other source, rest of the traffic, these traffic will be denied. Okay. So these traffic will not work, as simple as that. Now let's go back over here. Okay. Now we have to match whether we have the correct label being applied on this network policy and it matches with the front end pod. So if we do k get pods hyphen hyphen show labels, okay, and front end pod is our voting application, which is this one, and here we have the label app equal to vote, but what we have used app equal to front end. So that's why it is not allowing the traffic, because it's denied. What's not been allowed, it's denied automatically, right? So if we're gonna do k get, sorry, k edit net policy, we only have one net policy, so we don't have to specify the name, it will open it by default. And over here I'm gonna press shift a, I have to make this change, match label app equal to vote. Okay, I will be saving it and the policy is now edited. Now let's do a describe on that again. And over here it says now traffic is allowed from port where app equal to vote is the label. Let's go back and let's enter again. Okay, let's provide vote and it accepted the vote. And if we go back over here, did it refresh? No. Okay, it did not make the change. That means our result application did not accepted it. Let's try this again. Okay, now we have changed the vote to dogs. Okay. Remember this as well. Only you can change your vote, but from one browser, from one IP, you can only provide one vote. So this is a simple application. It does not have a lot of feature, and that's one of the limitations of it. So now it's not showing the votes over here. So something is still wrong with the application. So let's go back. Now we have looked everything. Now it accepting the vote. That means where is a diagram? That means till here it's fine. But now somehow there is some issue with either the backend, okay, the .NET worker or the database. Okay, so let's look into those now. So if we do k get, now the result is coming, like it's not the updated result, but still there is something. So that means the service is running. Let's see, k get pods, and our pod was result. Okay, I'm gonna copy this. K describe pod. It doesn't have any errors. It is running, and app is result. Okay, I don't see any issue. If we do k get, sorry, let's do a k logs on this. It says relation votes does not exist. I guess this is the error from the previous result. So let's try to restart this pod. Okay, so what I'm gonna do, k delete pod result. Okay, because it's controlled by deployment, it should automatically create a new one. So k get deploy, and it should have been restarted. Let's see. Yeah, 11 seconds ago result. Okay, let's go back, and why it is not showing the results now as well. Let's go back and let's see if we are still getting any error in this. K logs. Okay, it says waiting for DB. That means there is some issues with connecting to DB. Okay, so let's do a k edit. Let's look at the deployment. K get deploy, k edit deploy result. Okay, let's verify this. So there should be a database connection string and everything over here. So app label match is result, and then image on port 80. A replica is 1. No, there is no DB connection string over here. So yes, that's okay. Now let's see the worker one. Okay, worker is the one that we should be looking at, because this is what responsible for storing the votes into database, and that's not working, right? So k edit deploy worker. Okay, it says match label app equal to worker image. Okay, I don't see any issues with this as well. CK describe svc db. Okay, db service exposed on 5432. This is an internal selector app equal to db. That's okay too. Get svc, and let's do a k edit deploy db. Match label app equal to db. Okay, so here are the connection string for database. We have Postgres user. So this is not really a good practice to put your username and password as the environment variable. Usually we use secrets, or we use a third party secret management service like HashiCorp Vault. We have Azure Vault service, Azure Key Vault. We have Google Vault, and so on. Like there are different services offered by different providers. So, and this is not the way, but just for the demo, and this is a simple application, we are using this. And it says it's exposed in container port 5432. Name is this. And here is the mount path. because this is a database. It has to store the data persistently. That is why we are using a volume mount for this. Okay, and I don't see any other issues with the manifest. Okay, so let's see k logs. Okay, let's do k get pods, and let's do k logs. We have seen the worker one, and which one did we restart? We restarted the result. Let's restart the worker as well. Okay, delete pod and then worker. Okay, it restarted. Let's see. Okay, change the word to dog. Okay, let's see if it is working on this particular worker node. That could be the other thing. Okay. No, there is still something missing. It should show cats as 100% of the vote because we are only providing one vote. So I basically tried everything and I have checked some of the open issues with this application. So there could be something specific to the Linux image that I'm using. Maybe what you can do is you can try to like if you have fixed all the issues like what we have seen till now and everything is working fine, then that should be more than enough from this demo perspective. This is an application specific issue and you shouldn't be worried about it. So I hope now you have understand how do we do the application troubleshooting, and this is just for the exam perspective. There could be hundreds and thousands of more issues when it's come to real time application troubleshooting, which we'll be discussing sometime later on after we are done with this series. So thank you so much for watching. Thank you so much for supporting till now. I will see you soon with the next video. In the next video we'll be looking into control plane failures, and that's some another interesting concept, so we'll be looking into that. And yeah, that's it. So thank you so much and have a good day, happy learning, and I will see you soon.